As I was saying in the previous video, our aim is to find out the derivative of, let's say, sine of x or cos of x. And in order for us to find out the derivative, we need to set up this system here, where we set up points A and B, and then take the limit as h tends to 0. You see, this limit here is quite hard to work out because the hard part is this bit here. We need to be able to break into this. And the way we break into this bit here is to use one of the following here. You see, the aim of this video is for me to show you how we can come up with these four equations here. Okay, and if you look at this here, sine of x plus h, we would then use, well, here we've got sine, cos, and for us to use sine here, this bit here, sine of x plus h. So plus is here, negative is here, so we've got to use this equation here. You see, later on when we come to work this out here, we're going to have to break into this. So basically, this bit here is exactly the same as this. We would then visualize it as one block multiplying another block plus this block multiplying with this block here. You see, it's better to use this here rather than this, because once we can visualize it as this here, we can visualize it as blocks here, and then we can manipulate it. We can then manipulate it and move it around. Okay, so the aim of this video is to see how we can get to these four equations here. Okay, so to do this here, visualize the circle, a unit circle. So visualize this circle where it has a radius of 1. So from here to here is 1 whatever, 1 meter, 1 centimeter, 1 whatever. It has a radius of 1. Now, because we're trying to investigate sine of alpha, well, sine of cos one angle plus another angle, or sine one angle plus another. Well, as we're trying to investigate one angle, adding another angle, we've got to stack. So from here to here is alpha, from here to here is beta. So we're going to stack one angle on top of the other. So for example, alpha is this angle here, okay? Beta is this angle here. Now, because we're trying to investigate, let's say, sine of alpha plus beta, so we're going to stack. So this is alpha here. We're going to stack beta on top of alpha, okay? So hang on. So this here is alpha. This here is beta. Because we're trying to investigate the sum of the two, we've got to stack one on top of the other. So this here is a combination of the two. Okay, so this here is a combination of the two. Now look at this segment Q and S here. Hang on, let me think. From here to here is beta, and then from here to here is minus beta. The point that I'm trying to make is that this segment here will be exactly the same as this segment here. Okay, it will be the same, because look at this here. Hang on. At the moment, you've got this segment here. This is alpha plus beta. Okay, and now consider Q and S here. Consider that. Hang on. So at the moment, you've got this here. Now, if I hang on, bear with me. If I do this here, hang on. So currently you've got this here. Bear with me. If I what I'm trying to do is I'm trying to show you that this segment is the same as QS. Hang on, I'm rotating it here. So you see, it is exactly the same. So here, you see, this here is PR here, and this here is QS here. They're exactly the same. Okay, so what I'm trying to say is that when you have when you have positive beta here and negative beta here, the PR would be the same as QS. Okay, so this here is exactly the same as hang on. is exactly the same as this here. So it's exactly the same as QS. Okay. So hang on. So that's exactly the same. Our aim here is to get. You see this length here will hang on. This length here, PR here, the length here will be the same as QS. Will be the same as this length here. So what I'm saying is that PQ here. Sorry, sorry about this. Hang on. What I'm trying to say is that PR here, the length PR is the same as the length QS here. They're both the same. So this length here, okay, is the same as this length here. So our aim later on is to get is to come up with an equation for this length, okay, and then we're going to make it the same. We're going to put it into an equation equals QS here. So equals this thing here, because we know that these two lengths are the same. Okay, so now using Pythagoras, hang on. So now our first aim is to find out the length PR here. So we're going to use Pythagoras. So imagine a right angled triangle here. Okay, so we've got draw a vertical line down here. So this is our right angled triangle here. Okay, so we can now use Pythagoras. So at the moment we've got this triangle here. This is P and this is R here. Okay, and our aim is to, well, we know P R squared equals this length squared plus this length here squared. Okay, so basically to get the length PR here, which is PR here, the length PR squared, so it's us using Pythagoras here. Draw a vertical line down here, you will have yourself a right angled triangle here. Okay, so you need this length here. So you need to square this length. Well, this length here is actually this bit here. Why? Because if you think about it, from here to here is 1. Because we defined it as 1. We made the circle to be 1. So the length from here to here is 1. That's this one here. Remember, we're trying to work out this small length here. We're trying to work out this small length here from here to here. So what we do is we get this whole length here, which is 1, take away from here to here, and yeah, so take away from, if you draw it vertically downwards here, this length from here to here is actually cos of alpha plus beta. Because if you try and visualize this triangle here now, I know originally our original triangle was this one here. Okay, our original triangle was this length here. We ultimately want to find out this length here. But in order to find out this length here, we need to consider this triangle here. We need to consider this triangle here. And this triangle here has an angle of alpha plus beta. We need to consider this triangle here. Okay? We need to consider this triangle here. And this triangle here has an angle of alpha plus beta. So what you do, so if you've got a triangle here where you've got an angle of alpha plus beta, then this length here is really cos bracket alpha plus beta. So basically, hang on. If we ultimately want to know this length here, but to work out that length, we got to get this length here, which is 1. Take away this length here, which is cos alpha plus beta here. So hang on. So this triangle here is this one here. We ultimately want to find out this length, but in order to find out this length here, we've got to consider this triangle here. This triangle here has an angle of alpha plus beta. So what you do is you get cos alpha plus beta. That will give you this length here, and then get 1, take away cos alpha plus beta. That's why you've got this term here. Okay, and don't forget we've got to square it because we're using Pythagoras. Okay, so really our aim is to find out this length, and this length here is given by this. So we square it. Okay, now we've got to find out the height. Well, the height. If you want to know the height of this triangle here, if you want to know the height, it's really just sine alpha plus beta. So hang on. So originally we wanted this triangle here. We wanted this triangle here. But then to find the height of this triangle here, we have to consider this triangle here. Don't forget this has an angle of alpha plus beta. So to find out the height here, we would just get sine alpha plus beta. Okay, and then don't forget we've got to square it because we're using Pythagoras. Okay, I will continue in the next video. But so far so far this length here is given by this, and the height here is given by sine alpha plus beta. But we've got to square this. We've got to square this because we're using Pythagoras. Remember. Okay, so I will continue in the next video. Okay.